seminar because my camera is very high up.
Okay. So we may start in a minute. Okay. Yes, please, Eric. It's your turn.
Okay, yes, I can start then. Quick introduction. My name is Rein-Erik Hammer, and I am a virtual reality and augmented reality specialist from the University of Tartu's Computer Vision Lab. And I have worked there for 4 years. So this seminar is based on my experience and the feedback I've gotten throughout my years of working with VR and augmented reality. In terms of systems that I've used and I've developed on, it ranges all the way from complete virtual reality on HTC Vive and similar systems to mixed reality on the now discontinued Dockery smart helmet and augmented reality on Gear VR and phone applications. So those were my main expertise. But let's talk about VR and user interfaces and user experience and how to design everything. Now, VR and AR are kind of a complicated subject because it's a new media compared to other devices. Designing user interfaces for it is not something similar to what we have currently. The best parallel that I can give with designing user interfaces and user experiences for VR is how in the 1980s, we had the first Macintoshes shipped out, and they came with these computer mice. So everyone is aware of how to use a computer mouse. But back then, this was kind of a new subject. So people didn't really know how to use them. The Macintoshes did come with tutorials how to use them, but there was no standardization. So people thought they were used as a remote, or they had to flip it upside down and use the trackball to actually maneuver around. And VR is kind of in a similar situation, especially AR. And the novelty of it allows users to create and developers to create very different types of UI interfaces. So in this seminar, I'll just be giving an overview of what I've learned, things that I've tested, things that I've seen, and things that I've seen to work out quite well. Now, when moving on to VR and when I talk about virtual reality, the first thing that comes to mind for most people is a surreal environment or something completely virtual that you have in this current environment or a completely virtual one. So let's say you have a virtual object in a virtual world, or you have some virtual designs or models of stuff in a virtual environment and how you interact with them and how you move around. But in reality, the first thing when you launch a virtual reality application, the first thing you see is the user interface. And that is also the main thing you'll see most throughout. And how you interact with the virtual world is also based on the user interface. So I will be talking about that. Now, when going into virtual reality, compared to traditional media, in traditional media, you have 2 degrees of freedom. You have up and down, and you have left and right. In virtual reality, you have a couple extra degrees there. 1 degree you have is forward and backward. So your user interfaces or designs or models can be layered on top of one another. And you also have the ability to look around. So you can rotate your own view into a completely different direction. And this means that you can have user interfaces that are essentially layered on top of one another. So you may have something hidden behind something else, and this might be a complete good design element. When talking about designs, you might think that you have all this 360 degrees of freedom. You can look around and you can have massive user interfaces that are covering your entire screen. You have so much information built into it. But through testing I've seen, and from what I've heard from others, is that this is not really the case. Comparing to traditional forms of user interfaces, virtual reality and augmented reality user interfaces work best if they're more close to Android or phone-based user layouts instead of desktop environment layouts. So they should be simplified, they should be centered, and they should be concise. So if you press something, you get another pop-up, then that one should also be concise with the previous one. So you always have the back buttons in the same place, you have buttons in similar locations, you have information in similar location. That way, users don't get lost in the menus. And with virtual reality and layering of user interfaces, you can layer these interfaces. So you can put them side by side or right next to each other or in front of one another. Now, one thing that you should definitely avoid when creating user interfaces in virtual reality is screen pop-ups, so screen space pop-ups. Normally, when you're creating 3D environments, so not in virtual reality, but on a desktop environment, you might need pop-ups. You might need information on your screen space that conveys things to the user. Things like how things are going or the back button and stuff like that. But in virtual reality, these are more of a hindrance and they take the user out of the experience. So most of the time I suggest avoiding these entirely. But when working with Android applications or iOS applications that are augmented reality on the phone, so you just have your phone there and looking around and these are not glued to your face, then in those cases, it is okay to have a couple user interface elements on the screen, but only those that are frequently used or are very important and quick access things. Sometimes like spawning an object or selecting which object to spawn might be very important in some applications. So it's good to have them there. Now, why I'm talking about having these screen pop-ups and why they're so bad is that the human eye, if you have something on your head, if you fix the neck, then the human eye can only look 30 degrees left, 30 degrees right, and up and down is the same. So that is essentially how much your eyes are comfortable looking around. And this also moves on to where to place your user interfaces and user interface layouts. This white area here I've denoted as how much your eyes can see, and the black one I've denoted is where your neck comfortably can still move and look around and see things. So while your eyes themselves can have 60 degrees of vision, that is a comfortable movement, your neck added to it can have an extra 120 degrees of freedom in total. But it's not just that. There's one more extra element to this, and that is the horizon line, how far up and down you should have your elements. And the funny thing about it is that your neck actually is angled downwards. So your entire head is actually looking downwards, and your eyes are looking upwards. So your head is angled downwards about 10 to 15 degrees, and your eyes are looking upwards quite a bit less. And in total, your horizon line, the one you're comfortable looking at, is 6 degrees lower than the actual horizon that you have in any environment. And that is generally the best place to put any user interface when you're doing full immersive virtual reality or augmented reality systems that have virtual displays in the real world. Now, about text. This is very bad. Having text, not just having it in the user's like screen space, but having it in the screen space in general in any way is very bad. For one, if you have something that is covering your face, you won't be able to move your eyes quite that well, so you won't be able to see everything here. And even if you do make it smaller so it fits into that 30-degree space, it is still very difficult to read. So generally, text in screen space is bad. So if you have any sorts of information that you want to convey to your user, have them in the world space of your virtual environment. So let's move on to sizes. There's this thing about interfaces and things you have in the virtual environment, and something that aligns to designing user interfaces in the virtual environment itself. And that is, you're no longer limited by size. So your user interfaces are not always small or large, because a distance plays a part. So your user interfaces can be further away from the user, or they can be closer to the user. And because of that, some interfaces may seem larger and some interfaces may seem smaller. So for instance, here we have 3 user interfaces, but they're all at different distances from the user. And because of this, instead of talking about the normal pixel size of text sizes and centimeter sizes, or how big you want your UI elements in inches, you have to talk about angular sizes. So instead of fixed sizes, they're angular sizes. So something that is close to the user is much smaller, and something that is further away is larger, but they appear the same to the user. And on this topic, Google has put a lot of time into developing a standardized system, and they figured out a very simple system, which they call distance-independent millimeters. So 1 distance-independent millimeter is essentially 1 millimeter at 1 meter from the user, or 2 millimeters at 2 meters from the user, 4 millimeters at 4 meters from the user. So this is very consistent, and it's very easy to implement. And through their testing, they've also noticed that having it so for UI elements, this 1 millimeter at 1 meter, 1 millimeter can be 1 pixel, because the human eye cannot distinguish those pixels quite so well. So for most use cases, user interfaces following this rule, you can have a very simple system of developing UI elements and testing them at the same time, and keeping them concise throughout your development phases. And Google has also developed text sizes that are best for different applications. So these are all translated into those distance-independent millimeters units, and they're all tested by Google and promoted by Google. So everyone would use a similar system. So these are the easiest to read texts at specific sizes. Now, thus far, I've been only talking about flat, linear user interfaces. But in virtual reality and augmented reality, you don't have to have flat user interfaces. You can have them curved, and you can also have them bent, so that you have several screens where you have information, and each of them might be slightly bent towards the user or bent away from the user, all conveying some sort of information. And if they're bent, they can cover more of the screen space and be more natural for the user to follow along. Because if they're not bent, then things start skewing the further away they get from the user. But this bending also has some rules that you need to follow. In this case, I have made so that the bending is the point at which these screens are bending around is the location of the user. And through testing, both I have seen and I have read that people tend to get claustrophobic, especially if you have lots of screens or screen space causing following this bending rule. Because of this, it is a good idea to actually keep the pivot point of the bending slightly behind the user. This keeps the user interfaces slightly dynamic and immersive, while at the same time not feeling too claustrophobic for a user. So these are still bended, if you can see here. Also, do not bend small user interfaces. This is never a good idea, just keep them flat. Now, moving on to user interfaces that actually follow the user. So you might have cases where you have quick access tools that are very important to the user, and they need to continuously touch them or use them. Things like spawning in objects or accessing the actual menu of the application itself. In that case, it is a good idea to have smooth following user interfaces. So things that don't just pop into existence in front of you and seem like they're slightly skewed in the screen space, but things that actually look and feel like they're in the virtual space, but they're just following the user. And in this case, it is also a good idea to have some sort of pin function so that the user can get rid of these interfaces and put them somewhere where they're left, and the user then can later come back to these and interact with them as they wish. But this also leaves two other types of user interfaces, those that are completely stationary blank pages, and those that track the user's position. And you might think that it is best to always use the tracking ones if you have interfaces that need to stay somewhere. But in actuality, the stationary ones also serve a good purpose, because the tracking ones will always take the user's attention away. The user will think this is something they need to interact with and they need to go to and do something with. But if you have stationary ones, these might be virtual screens that the user needs to interact with only when they get near the screen or to the correct location based on the screen. So let's say you have something behind the screen that the user needs to look at and understand what is happening, but the screen should not always look at the user, because the user might get the wrong impression and walk up from behind it and think that they're supposed to be looking in that direction, while what you're actually looking at is here. I got a question here. Does the smoothness depend on the monitor? Was it? The smoothness here, this depends on the application and is very much dependent on your own testing and your own experience. I have not found a specific smoothing that works best in all cases. Sometimes very slow user interfaces are very good, especially if you're using center tracking. So you have a raycast from the center of your screen and you don't have any controllers. In that case, very slow following or very slow smoothing is preferred. While if you have, let's say, controllers or hand gestures, faster smoothing or faster following is even preferred. So it all depends on the user inputs, and it also depends on the use case where you're applying this. I cannot read that properly. Bent screens in VR. Okay, I can't read the last part of that, but I'll just move on. Now, currently we have covered screen types, and following screens, let's also talk about when you go on to screens. Yes, yes.
Eric, the question is on bent screens. Are they mostly used in VR, is the question.
Oh, no, they are used outside of VR as well. You can have normal 3D environments that you use on your desktop, and these can also have bent screens inside of them. So if you have, I don't know, a first-person shooter game, you might have bent screens inside of that as your user environment. But bent screens, this is something that from those systems can be translated to virtual reality and augmented reality, and they work quite well. So this is something through testing that works quite well, and people tend to like it and prefer it, especially because it stops the distortions from the edge of the screen. Now, moving on, when we have these sorts of interactions and buttons in virtual reality, and especially if you're using a raycast from the center of your eyes in order to interact with menus, sometimes these are not that accurate. You might press the wrong button, you might accidentally click on the wrong thing, and you don't know what would happen. So a good idea and a good rule to follow, especially when there are more important things happening in the screen, let's say you're transitioning into the next phase, or you're transitioning into a different scene, or you're doing something irreversible in the scene, then it's good to have confirmation buttons, much more so than in traditional user interfaces. Because in traditional ones, you'll most likely see and read the text and see that this is something you cannot reverse. But in virtual reality, you might accidentally click on this because you don't always notice it. You can't tell where both of your arms are at all times and what they're pointing at, or you might not notice that the laser pointer that is fixated on your screen might be clicking on something while you're trying to read what is actually on that button. So confirmation buttons are a very good thing. Now, something regards to the degrees of freedom that we have in virtual reality. In normal desktop applications, you sometimes see rotary menus or menus that are in 2 dimensions instead of 1 dimension. And you might think that virtual reality actually prefers these sorts of rotary menus and 2-dimensional menus and 2-dimensional menu interactions compared to the normal 1-dimensional sliders and stuff. But through testing, I have actually seen the opposite. People tend to prefer simple sliders to something that might rotate and be finicky. So sliders and 1-dimensional user interfaces are much more accurate for users in virtual reality and virtual spaces. And another thing about virtual interfaces is that you always have that depth information. You know how far things are. So if we look here, user interface is not flat, layered on this backplane. Everything is slightly layered. So if you move to the side, and this works best if you actually have virtual reality goggles or something on you, then you see that everything has this sort of a parallax effect, that some of the objects are closer to the user and some of them are further back. And this gives a sense of depth for the user, and that they're not just interacting with a flat plane. Now, when you're designing these sorts of user interfaces, you might be tempted to use all sorts of transparencies and colors. And in this case, you might see that the right one here is much harder to see than the left one, because the left one is dark on this background and the right one is very light here. But you have to consider the user's use case, because sometimes you might have backgrounds where, or use cases where the user just doesn't see your user interface. So it's good to have these multicolor borders, especially that transition between light colors and dark colors. This applies specifically to augmented reality, but it also kind of applies to virtual reality. Because in virtual reality, you can always define what your environment looks like. So in this environment, there are not that many dark areas that the user would look at, while in the real world, the user may look at anything. Their environment might be completely orange, and if you have a completely orange layout, then the user won't be able to see or read the text that they're trying to follow on those augmented reality applications. Now, moving on to Android-based user interfaces. Normal applications that you have, or things that you might interact with, have all sorts of these user interfaces that follow the user, look at them, and they're easy to click on, they're nice and large and bold, they're easy to distinguish. But if, for instance, you take this object that you're interacting with and throw it away from the user, then the UI will get smaller, and you won't be able to see the object anymore, or you will be able to see the object, but you won't be able to interact with it anymore because it's too far away and your thumb is too large or your finger is too large to actually press on the screen. So in those cases, it is good to have screens that actually resize based on the distance. This is specifically for Android or iOS augmented reality applications. So normal phone-based augmented reality applications where you use your thumb for interacting with the augmented environment. But this distance-based information also serves another purpose, and that is when you have too many pieces of information on the screen. So you have, let's say, a bunch of menus that you want to show, all of them displaying different things. And how do you try and show all of these at the same time? I personally have a project that I'm working on right now that is trying to show human bones in virtual reality. And all of these bones need to have labels for where are these flat surfaces, where are the connective surfaces, where are the holes where tendons attach to, where are the holes where blood vessels go through or nerve endings go through. And this is all very vital information for medical students. But at the same time, if you take a full skeleton and then try to display all of that information, this will get so cluttered that you just don't know what the heck is happening anymore. And in virtual reality, because you have the ability to move where you're looking and where you're placed in the virtual environment, then distance is a good way to actually show user interfaces. So interfaces that are close to the user should sometimes be shown, and interfaces that are further away should be either hidden completely or shown as small pop-ups that the user should get closer to them to show these user interfaces. Here comes a difference with normal traditional 3D environments and virtual environments, and that is collision. In normal environments, you probably can't walk through, or not normal, in 3D environments, if you don't want the user to walk through a object that you have in space, then you just have a collider attached to it. But in virtual reality, you can't do that. The user can just use their head and pass through these objects. And this will create conditions in your scenario that might confuse the user. They will not understand what is happening. They might get confused, or they might think that this is an intended purpose. And often cases, mostly what I've experienced with my user testing, is that users look at some sort of an object that they're trying to figure out, they go inside of it, and then they no longer understand where the object is. And they think that the object is just lost in space somewhere. Well, in actuality, they're inside of the object, and it's no longer rendering for them. A very good trick to combat this is to have areas inside of colliders that apply filters to the user. Things like a blurring filter. This will give feedback to the user that they're somewhere where they're not supposed to be, while at the same time not being too intrusive. So there's no point in giving a large pop-up in the middle of the screen saying that you're out of bounds or something, because it might be too intrusive and bring the user out of the experience. But something that just blurs the screen will be less intrusive, but also give enough information to the user that they're somewhere where they're not supposed to be, or at least they should pay attention to something else. And these UIs that we have can also indicate that something is correlated to something else. So you don't always need a whole bunch of UIs for everything. You can have UIs that are correlated and keep them together. And when you have a virtual environment, a big problem that VR developers have, mostly with their applications, and what I've also experienced quite a bit, is how to get the user to actually move in the virtual environment. People might put on the goggles and they'll just look at one place, stare there, and not do anything. They will just keep on looking there and wait until something actually happens. And people generally don't get this, that in virtual reality, you have the option to actually move around and look at objects from different locations. It might seem trivial, but users still need guiding for this. Because of this, it is good to have either small user interfaces further away from the user, where the user can see them at the start of their scenario, that either indicate for the user to go somewhere, or it is a good idea to give the user tasks at the start so that they should do something in particular. That way the user will start figuring things out instead of being stuck there waiting for something to happen for them instead of, another way to get the user to look around things instead of looking at one thing from one particular angle is how you present objects in virtual reality. And that is the reason I have a sphere and a couple of cubes here. Most of the time when you bring out an object in virtual reality, the area that you're denoting under this virtual object, or the playground that you're denoting, the simplest thing to put there is just a cube or a square. And this might be very easy to implement. This is very easy to texture. It's easy to put everything around it and whatnot. But it serves one very negative purpose. And that is that the user knows that this is the location that they're supposed to be in, and they're not supposed to pass these corners. And if you have a virtual system, then the point is for the user to actually walk around it. That's why it's actually better to have circular planes under objects that you have. That way the user won't know what is the front face and what is the side face. So the user will walk around it and actually explore your environment. So let's walk here. And sizes also play an important role in virtual environments. In this case, these large objects, the user might think that they need menus to interact with them, or they're pieces of scenery. So in virtual reality, they will not interact with these at all. In augmented reality, they might just look at them, look around them, but not touch them in any way. But if your objects are small, so close to something that you could pick up in real life, then the user will most likely try to interact with these. And that is one way of guiding users, is to have these small objects that they can actually interact with be interactable. And one thing you should definitely avoid is having a scenario where you force the user to back up. So in virtual reality or in augmented reality, you should never force the user to back up from where they're standing. They should always go forward, look around, and then move forward to that direction. They might strafe slightly to side, but it kind of is dangerous because they might bump into something. But backing up is a very certain way of bumping into something or falling over. So it's kind of dangerous for the users. In this case, this large screen does serve another purpose. And that is, it's so large that the user can't look at it when they're close to it all at the same time. So it also forces users to look around and observe the user interface or the object that you're placing in virtual environment. So this is both a good thing and a bad thing, and you need to test and see how it actually functions in your specific use cases. But if you have these sorts of problems where, let's say, you have brought the user here, but you somehow need to bring the user back, then let's say the user is in the real world, they're using an augmented reality system, but you want to bring their attention away into the menu that you have somewhere. Then you can blur the environment. That is a very subtle way of telling the user, don't pay attention to this here, pay attention to something that is not blurred and is right here. Because if the environment is blurred, the user will start looking around and trying to figure out what is happening. And if their eye comes across something that is very sharp, they will look at that. And that's where their attention will be focused. Now, when talking about augmented reality and virtual reality, you have this one freedom as a developer, that you have lots of room to place things. You have 360 degrees of freedom where to place things, and you have the entire environment that the user is currently in to place all of these things. And that is actually kind of a problem, because this can cause situations where the user feels very claustrophobic, that the designer has put too many things there. So try to limit what you actually give the user or what you place in the user's environment, or at least try to keep their sides and back empty or sparse, so that the user feels like they can still move around and they're not confined to this small space that you force them into. Now, this also applies to if you have virtual or augmented reality spaces that have multiple people in it. Because, well, as a developer, you can say that, okay, I won't place all of these objects so close to the user, and I won't place so many of them. If you have a multi-person or multiplayer environment, and you have all other people in this augmented reality environment or other people in this virtual reality environment, then those people can group up and go close to other people. And this kind of encroaches on people's personal space. And this is actually kind of problematic in virtual reality, because you can get very close to someone else. You can even go inside of someone else, because there's no feasible way of stopping collisions without breaking the immersion of the virtual space. And one way of doing it, and a couple of virtual chat interfaces have used it, is to force users that are, or user models that are too close to other users to just simply go invisible. And generally, I have read that the distance for this invisibility is around 1/3 of a meter, or somewhere inside of 1 meter. So if you're developing some sort of a multiplayer environment that has multiple people in virtual reality, then make sure that their models do disappear if they're colliding with one another or are too close to one another. And talking about all of these things that you should not do, I have a small list of things that also have learned, and some of them might be very intuitive. Some of them you might not realize at the start, or you might not have thought about. And those are things like forcing the user to move, or moving the user without their consent. That also includes accelerating the user when they're trying to move. In virtual reality, this can be very nauseating. In augmented reality, it can be even worse. But in virtual reality, if you try to move the user without their consent, then they will lose their sense of balance and might actually get sick. A way to get users to move from one place to another is either give users full and complete control of how they move, or use these controller-based teleportation systems. And generally, teleporting in virtual reality seems to be much more robust than just moving around, because the users don't have that much space to walk around. And if you try to force them to move in the virtual environment while they're not actually moving in the real environment, then you get bad things happening. And if you're doing these teleportations or transitioning between scenes, then just popping these in and out is also a problem. A good thing is to have slight fade-ins and fade-outs, because all of this is covering the user's vision completely. They can't just look away or focus on something else. This is completely in their field of vision, and it's just taking everything over. Also, when you're trying to draw attention to something in virtual environment or augmented environment, do not apply any zooming effects. So I know a couple of games that do this in order to draw attention that the user is currently talking to a person in the virtual, the 3D environment. So games like Oblivion or Morrowind, they had these systems where if you encountered an NPC, so a person you're supposed to interact with, and you talk with them, then the camera forcibly zoomed you in on that person. And that is something you cannot apply in virtual reality at all. This just throws people out of balance, and they just get completely confused as to why they're zoomed into something. And the zooming in has a secondary problem, and that is you cannot force the user to look at something specific. You cannot turn their head against their will, because that will also throw them off balance. Now, I've put a whole list of things that you shouldn't follow. One more extra thing that I have here is don't remove floors, especially when you're in virtual reality. Just don't remove floors. You can remove them in augmented reality. Most of the time, you don't even need them in augmented reality, but in virtual reality, always have a surface that the user is walking on, and make sure that the surface is at a similar height as the person is in real life. Otherwise, it will feel weird to them if they're very short or very tall in the virtual world, or if the ground is too far away or too close to their head. Now, let's move on to scanning and augmented reality and user inputs. Now, if you have an augmented reality application that you're using, and it has the functionality to scan the environment that the user is currently working in. So things like ARKit come with these mesh detection systems that detect if you have certain objects in your real world environment, and they can detect them and apply them in the virtual environment as well, but as simple meshes. Or if you're using AR Foundation or AR Core or any of those other Android-based, or not Android, smartphone-based AR libraries or systems, then when you're developing these AR applications, it's good to have a way of giving feedback to the user that something is being scanned. It might be very simple that you just have an application that places down a chair, like an IKEA app or something like that. And you don't really need to know that the floor has been detected or whatnot. But in actuality, this is very important, because users that are using augmented reality applications on their phones don't always look around with their phone until something has actually happened in the augmented reality, and then they start looking around. But the problem is that all of these augmented reality systems, they require that the user looks around before anything starts. It needs a lot of data to start plane detection or mesh detection or point cloud detection. And because of that, it is a good idea to give some sort of a feedback to the user that either they should move the screen, or that the scanning is currently happening and they should do something with it, or the surfaces have been scanned correctly and what they're now working with is completely visible. And don't keep those meshes or ground textures on the screen. Show them once, let them disappear in a second, or allow them to pulse every couple of seconds. That way the user is kept up to date on what is being detected and what they can actually use as their working planes. Now, virtual reality and augmented reality comes with many different forms of interaction. The ones here are 6 degrees of freedom systems. Basically, you have a completely separate object in virtual reality that is completely tracked in virtual reality or augmented reality, and the user can basically use this as a controller. But there are many more types of controllers out there and interaction methods out there that you can use. The simplest there being just touch-based inputs. So if you're using an augmented reality system, you're just pressing and clicking on something or dragging and dropping. That's the simplest method. The next one there would be a raycast from the center of the screen. So when you're looking around, you have a laser pointer from your screen, and this, if it is stopped on, let's say, some sort of UI interface, and you wait a second or two, then it clicks. This is very common, especially on systems that don't come with these hand-based controllers, but they're full immersive, so they're covering your head. So you cannot use your fingers to control anything. Notably, the Dockery Smart Helmet used this sort of input, and that was the only sort of input it supported. We have the 6 degrees of freedom sorts of devices, and we also have 3 degrees of freedom devices. They're slightly less common, but they also exist, and they're much simpler. They usually come with smartphone-based VR systems. So Gear VR-based systems, some of them have the small controllers that are displayed in your virtual environment, but their location is not tracked. Yet again, their angle is tracked. So you can use them as laser pointers or as systems to grab something in the virtual environment, but you can't really pull them away or closer to you or move them from side to side because they're not being tracked that well. And the last type of input that you have, and generally is the best one and most preferred one if your application can have it, or your hardware can have it, is gesture-based or actual hand detection. But that one I'll talk about slightly later. Now, when you have set up all of your virtual environment or augmented the environment and you're, let's say, interacting with it, and you want to place some objects into it. A good idea is to have volumes or some sort of shapes to indicate the size of the object that you're trying to place. So let's say you're starting an augmented reality application and you're running it in your room, and then you're spawning in some sort of a sofa. Then you want to know what is the size of that sofa. Can it actually fit in my room, and can it will it just take up the entirety of my walking space and I won't be able to interact with it in any meaningful way? Or if you are trying to play or interact with an augmented reality environment and it is condensed onto an augmented table or something, or an augmented playing field, then you want to know how big that playing field is. You want to know where you can place it or how you can place it. And you want to know if you have enough room to actually walk around it and see it from other sides besides the one that you're currently in. So it's a good idea to actually have this sort of pre-indicator. And it is also good to have a way to change the location of your entirety of your scene in your application later on. Because so many times it happened that the user uses an augmented reality application, starts it off, places the first object, and the object is, they think this is the first object that they're placing, but it is actually the only object they're placing. And then it turns out that they placed it too far away, or too close to themselves, or just in an awkward position, or they figure out later that actually the front side is on the other side, and what they're looking at is either the left or right side, and they need to walk around the entire environment, but they don't have space for that. So allow users to interact with objects that they've placed in augmented reality even after they've placed it. And then consider the limitations, especially of augmented reality. Now, on smartphone devices, I'm talking here. Now, in other devices, if you have these goggles-based systems, they might be very immersive, but you can't use them on day-to-day basis. People generally don't download these on app stores and stuff like that. So if you want an augmented reality application that is very easy to use and very easy to get into, it's probably going to have to be an augmented reality application that is just running on a smartphone and does not require any extra hardware to strap it onto your face. And in those sorts of systems, you need to pay attention to the fact that the user is now slightly immobilized compared to what they were previously. So if you're trying to develop an application that is, let's say, teaching the user how to use an espresso machine, then you have to pay attention that this application can give visual feedback on specific locations of the espresso machine, that here's what you do here, here's what you do here, this is the next step, you have to go around to that step and all that. But the user has to do all of this with one hand because their other hand is currently holding the phone. So pay attention to what you're developing it for and how you're developing it for. So in that sort of an espresso machine scenario, it might be better to have some way of either showing the user that, okay, this is how you do it, now please put the phone down and actually do it, or have it in a fully immersive goggle style and then just walk the user through as they work with the device. Now, let's move on to gesture inputs. As I mentioned previously, if the hardware that you're developing user interfaces or your virtual reality application or augmented reality application supports hand gestures or hand detection, then please use it. Because even if it is quite finicky most of the time, people tend to pick up on hand gestures much more so than the controllers for some reason. I've demonstrated VR applications in several, these are like large, not conferences, but large events where there are all robotics-based competitions and stuff like that. And in there, people come to your booth, they try on the VR headset, and they don't know how the controllers work. They take a while to understand them, but if you have an augmented reality system and they don't have any virtual controls in there, then for some reason people, their first instinct is to use their hands to grab something, even if that is not supported on the device. And through that, I've experienced that people tend to prefer using their hands to grab everything. So if you can, then use gesture inputs and gesture-based interaction. And an easy way to show users that do not use their hands, that their hands are actually part of the environment, is to have simple overlays on their hands. So virtual overlays. This tells the user that their hand is currently being tracked and they should use it. And these overlays should be very simplistic. They should not be very complicated meshes that follow the pattern of the human arm, but they should just be either cubes or balls or a simple bone mesh that is following the user's hands. Now, in terms of gestures, there is a toolkit called MRTK that is generally based for, not generally for hand gestures, but it is for VR and augmented reality development. And a large part of that toolkit is focused on hand gestures and how to use your hands for interacting with the environment. And they have developed a very good standard for interacting with the environment. So if you have a virtual object and you want to pick it up, then the most logical thing in the real world is to grab it. And that is how it is happening there. In their development software, you have to just pinch something and you grab it. Or you pinch something and drag it, and that either moves it, or if you're picking it from one of the corners, then it resizes it. Or you can rotate it that way. If you want to press a button, then you literally have to take your thumb or a finger and then press the button. This seems very intuitive, and people generally tend to understand it very quickly. The last picture here indicates how in that environment you can grab objects that are further away or interact with objects that are further away. And that is just a gesture that is almost like a grabbing gesture, but grabbing from a distance, and that also seems to be very intuitive to users. Now, with gesture-based interactions, you might be tempted to use gestures to draw or tell the user to draw what they actually want. So drawing shapes or drawing specific interactions or hotkeys in order to interact with specific pieces of user interface. But this also has its downsides, because you might have these sorts of gesture-based inputs on your phones where it is just X and Y coordinates, so two-dimensional systems. If you draw a square, the application is going to recognize it's a square. But if you try this in virtual reality or augmented reality, then it might look like a square for the user, but for the application, it might look at it from the different side and see that this is not a square, this is a circle. So these are just a couple of pieces of information based on user inputs. Now let's move on to realism. This applies specifically to augmented reality. Now, while most of the rest of the things have been for virtual reality or augmented reality, this one applies specifically to augmented reality. And that is, if you bring virtual objects into the real world, they will always look like virtual objects. But in recent years, there have been many developments and many different techniques in order to make those virtual objects slightly more realistic. So in this case, we have a virtual model, and this is placed in the real world. And you can see it is easily distinguishable from the background environment that does not belong there. Even if it is fully tracked and you can walk around it and it stays in place, it still looks like a virtual object because something of it seems slightly off. And let's go through the steps how to make it slightly more realistic, starting with a simple blob shadow. This is the simplest technique you can apply. So at the bottom there is now a shadow. This ties it into the environment slightly better. How can you make it even better? Is by sampling the background you have or what the camera actually sees, taking the average value of that and applying that as the lighting for your model. That way the model will be slightly colored the right way and lit up the right way compared to the background. So if you're running your application in a dark room, the model will be dark. Or if you're running it in a very brightly lit room, then it's going to be very light. Now, from that light estimation thing, there's been lots of development in machine learning on how to take the background picture that you have and estimate where the sun is or where the light is in that picture. And there you can get the next step, which is light direction estimation. All of these things that I'm talking about are already implementable in most augmented reality toolkits. So these are just things that you can slap on, and put on, and just continuously add them on until you have something very realistic. But right now I'm explaining what these are and where did they come from or why they're there. So right now we have sun direction estimation. So this one estimates that the sun is coming from behind. And based on the sun direction estimation, we can also get shadow real-time direction estimation. So in this one, the shadow was just here at the bottom. You can see the light is coming from behind and from the top right, but there's nothing behind the model that would indicate that the light is actually coming from that direction. While here, a real-time shadow is applied to the back of the model that also follows this light direction. And the next step here, and how to blend this model into the environment slightly better, is to generate these things called environment probes. Now, movie makers and filmmakers use these quite often when they're trying to make things look more realistic or more in the scene compared to everything else, or what they have that they are trying to bring into the virtual environment. And that is that if you have a virtual model, it has all of these tiny reflections. And in this environment that I have here as well, it has the same problem that all of these reflections are just gray, or it's trying to reflect off of that kind of blue sky. So it's all uniform. But if you can look at the background, you can see that it has all of these wooden planks. It's slightly orange. There's bluish in the background. There's a bit of green there. So something called a environment probe is created. So it's basically an estimation of what sort of color is being reflected from what sort of direction. And these can be generated in real time as well, called environment probes. And if you can compare these two, the one with the environment probes already has some slightly more realistic colors attached to the object. It has some greens, it has some reds. It's not just one uniform color anymore. And currently, in terms of what VR and augmented reality has developed, this is the cutting edge. And the only way to improve this currently is to use post-processing effects, like filters on the entirety of your screen to uniformly mix everything slightly better and mix it together slightly better. And this is where you can leave off your models so that they seem realistic. There are a couple other tricks that you can use that are unrelated to this. One of them being physics or physics interactions. So if you have models that you're interacting with in augmented reality, that they abide the laws of physics. So if you drop them, they actually fall down, or if you throw them, then they actually fly a distance. And another one that has been developed in the recent versions of AR Core and ARKit, and that is distance estimation. So you can apply volume fogs or stuff like that and tie your scene slightly better together. And one of the coolest things with this distance-based estimation is that you can have actual occlusions in your scene. So let's say you're using your augmented reality application on your phone and you have an augmented sofa, then if you're moving your view behind one of your chairs in your room, then that chair will appear in front of your sofa. So these are things that have been recently developed. And if you plan on developing anything augmented reality related, then do check these things out. They're quite cool. But this basically brings me to the end of the experiences that I have learned. But do keep in mind, all of these things that I just talked about, they're not concrete things. If you plan on developing your own virtual reality application or augmented reality application, these are just guidelines or things that I learned personally. I suggest you try out your own different methodologies or your own UI interface types. There might be something out there that is actually the best case user environment or user interface, and no one has discovered it yet. So do try everything. And if you plan on actually trying to develop things for virtual reality or augmented reality, then the best place to start, or if you want to become a virtual reality or augmented reality developer, the best place to start is watching either simple tutorials or going on the internet and trying simple projects. Everyone here has their phone. So everyone here has their Android smartphone or their iOS smartphone. And nowadays, these smartphones are powerful enough that they can use augmented reality applications. And that also means that you can develop augmented reality applications on these. And if you cannot develop an augmented reality application, then most likely you can develop a virtual reality application on these. So that's the best way to get started. For those of you who are already developers and have developed 3D games or game environments, virtual reality application development is very similar, but there are a couple of differences and a couple of nuances. I myself have taken lots of game development courses and these 3D environment development courses, and I've noticed something that they don't talk about there, but you need to keep in mind when you're developing something for virtual reality or augmented reality, and that is performance. In augmented and virtual reality, you're running your application on either a smartphone, which doesn't have a lot of capacity to it, or you're running it on a high-end system, but in that case, think of everything that is trying to run in the background, trying to synchronize everything so that you can use or have your virtual reality experience. That means simplifying and optimizing are very important things for virtual reality, augmented reality. Simple things like if you build a model that you want to show in virtual reality, try using lower amounts of polygons to show it, and instead of trying to get that level of detail with polygons, use normal maps. So normal maps are the things that bend the light and work in the shader layer. So they basically make models look very realistic, but at the same time, don't take up too much computational time, so the computer doesn't have to focus too much on rendering every single polygon. And if you are developing something for virtual or augmented reality, you always want to get feedback. The best feedback that I've ever gotten for my applications and the things that I've developed are from not my coworkers or peers, but from actually non-tech savvy users. So people who are either coming into virtual reality for the first time or people who haven't used it that much. They seem to give the best bits of information, and they can instantly tell if something doesn't feel realistic, or if you're paying attention to how they're acting in virtual reality, you can instantly tell that something isn't as intuitive as you might have guessed in your first implementation. This is mostly true for 3D environment developers or those who develop games already, that you have a fixed set of ideas on how to interact with an environment. But most people who come into this, they don't have those preconceived notions, and they won't know how to actually interact with the environment. And a good way to actually get this feedback, apart from talking to them and watching them how interact with it, is to use surveys. So very simple question and answer systems. And those surveys for virtual reality, I suggest putting those surveys into the virtual reality instead of having paperback feedback outside of it, because then you can have them continuous. The user can answer to your questions while working in the virtual environment, and they won't be interrupted. Well, if you have a pen and paper system, every time they need to answer some question or they get somewhere in the environment, they have to take off their goggles, they have to give you their feedback, and then they have to get back into the environment, and this breaks their immersion. Or if you want to get feedback at the very end of a scenario or project, then you have the problem that the user won't remember what happened at the start, or they might figure out things later down the line and then not talk about how difficult it was to actually figure things out. Now, and for those of you who are developing or want to develop augmented reality applications, a funny thing that I've noticed is how to figure out what is a good sign that your application that you've developed seems realistic enough to the user, to the point where for them it seems completely natural. And there is this one simple tail sign that tells you that the user is completely immersed and has forgotten that what they're interacting with is completely virtual. And that is if they're using a phone-based application. So this applies to phone-based applications mostly, but sort of applies to virtual and these goggles-based applications as well, is that let's say they're looking at something and they're interacting with it, and they want to read a different menu that is in the virtual environment, but they also want to keep their screen here. So they actually look in the direction where they know the information is, and then they get confused that this virtual piece of information isn't there. And then they realize that it's not supposed to be there because it's all in this virtual environment, and that is the real environment. And at that point, you've basically succeeded in telling the user that what they're interacting with is somewhere in mix between virtual and real. And the user has basically lost their ability to tell what is virtual and what is real. This can happen to even experienced users of virtual reality. If they use it long enough for some sort of an application, they might accidentally glance somewhere looking at a piece of information while not actually bringing their phone along to see it, look at it. And then they realize that, oh, I was completely immersed. So that is a very good telltale sign to basically tell if your application is working good enough. Now, quickly, I've been talking all about this VR development and VR user interface development and what are the best practices. But VR and augmented reality are kind of a niche topic, but they are increasingly becoming more of a mainstream topic. It's no longer just a simple gaming tool or a marketing tool for some companies. People are moving more and more towards using this as a way of training their staff or development, or so in terms of development, like building models or looking at your CAS, computer-aided design models in virtual reality so you can understand how they look like. Or if you're making mock-ups of planned building designs or any sort of mock-up. So virtual reality and augmented reality is moving in that direction, and it's becoming more and more mainstream and more important in our society. And if you look at Apple, Facebook, and eBay, and I think Google as well, yeah, there was a list of companies that I went through their hiring processes, or like what sorts of people they're actually hiring. And there's a whole list of people that they actually want to hire. I don't have them up on my screen right now, but these were 2019 and 2020 job positions that they were looking for. So Apple, for instance, had a user interface prototyper for AR applications, and they required experience in VR, AR, and Unity and Unreal. So this here is Unity, one of the main development platforms for virtual reality applications. Then we had Facebook, who wanted a product design manager who required knowledge on augmented reality and virtual reality input. And they required experience in Unity, Unreal, and game or interaction development. Then we have eBay, who had a visual designer. It didn't say anywhere in the title that this is for augmented or virtual reality, but if you read in the description, you could see that they also required experience in augmented reality and virtual reality. And then you had Amazon, who also required the design technologist, who, the full title was something like Design Technologist, Visual Search and Augmented Reality. And they also require experience in Unity. So all of these require experience in Unity or augmented reality or virtual reality. And the only way you can get this is by making your own simple projects or starting off in this field. And this is essentially where user interface development is currently heading nowadays. It's more and more virtual reality interfaces and augmented reality interfaces. The normal interfaces are still there, but this new niche is coming up and people are going to start to fill it. So it's a good idea to look into this and see if you might be interested. But anyway, this was my small seminar on virtual reality, user interfaces, and user experience, and what I learned from my development processes. If there are any questions, now would be a good time to ask, even if some of you asked during the presentation itself. Let me open the chat here, then I can better see if anyone has any written questions. So yeah, the smoothness question already asked. And the bent screens one, basically, there are bent screens and there are curved screens and there are flat screens, and all of them are used in virtuality, and they all convey different types of meaning. A large portion of it is what sort of atmosphere you want to put the user in, is what they kind of convey. So this completely depends on your own sense of what the atmosphere of your application is. But most of the time, if your screens get large, then it's good to have them bent in some way. But thank you. Are there any more questions?
No, Eric, thanks.
Okay. Then thank you for having me, and I'll give it off to Albana.
Okay, thanks a lot, Eric. It was really very, very nice. Well, if we don't have any other question, then we may close if you say okay. Any other questions? No? Okay, it seems there is no more questions, Eric. So I'd really like to thank you, and I hope we will meet very soon again. Okay, thanks a lot. Should I stop the recording now?
Have a great night.